of Bimflov Putane. A violent aerial dive executed at extreme speed toward a remote mountain valley in Hubei province, central China.
The projects being examined in this video are not simply large buildings or impressive structures, but rather deliberate acts of engineering.
The maximum temperature is holding steady at 22.5 degrees Celsius, well within the specification limit.
Into obituary Lucretize. The audio features loud construction noises, the rumble of heavy machinery, and the roar of a flow.
Initiating gate sequence test. Pressure holding steady.
Seal integrity confirmed. Data logging nominal.
Clear the lower deck. The gates are cycling.
The concrete held up well against the recent typhoon winds.
Yes, the drainage system is functioning perfectly, no sign of water ingress.
The gauge measurement on the C12 segment is showing minor deviation.
Noted. Checking the laser alignment now.
The pressure in shaft 3 is holding steady.
Good, but look at the flow rate on the auxiliary pump.
Control center, this is Yoshioka Kaite. Communication test successful. Over.
Attention passengers, remain calm and proceed to the refuge area immediately.
This sequence really highlights the scale of the challenge, from the andesite to this soft mudstone.
Indeed.
The gauge is showing 25 millimeters deviation at this joint.
Okay, noted. Pushing forward to the next section.
Monitor the undersea section closely.
Verifying separation distance for the Shinkansen and the freight. All parameters green.
The rebar cage alignment needs adjustment on the north side.
Okay, I'm signaling the team now. Ensure the supports are secure.
Make sure the wires are routed correctly to the acquisition box. They are secure. We have a signal transmission.
Check cable tension on M42, transducer reading 3450.
Looks consistent with the design parameters. Confirmed, dead load distribution is stable.
I'm not seeing any visible damage on the lower sections. It's solid.
The aerodynamic design definitely performed as expected.
The sinusoidal pattern confirms the deck is moving exactly within the designed expansion range.
And the seals are functioning correctly. No debris.
The reading is 4.2 millimeters on the tidal zone.
Cross-referencing the baseline data, looks like a 15% reduction here.
Control to Sector 4, we have a stalled vehicle on the eastbound span. Dispatching freeway patrol and requesting immediate TOW.
Readings look good. No significant thaw detected.
Agreed, the permafrost is stable here.
The sensor reading here confirms the target temperature is maintained.
Good. The heat extraction rate seems sufficient for the season. The displacement here is significant, likely due to the differential thaw.
Yes, the thermal stabilizers aren't fully effective in this section.
The reading is stable at 6.5 liters per minute.
Confirmed. Within specification. Next nozzle.
Try tapping right here near the expansion joint. Okay, running the sequence now. The data looks consistent.
200ths at benchmark, Charlie.
Holding steady.
Roger that. Logging the data now.
Thrust pressure holding steady at 40 bar.
Conveyor clear, systems green.
Erector arm secured, ready for rotation.
The bolt pattern is secure and the shotcrete thickness is verified. We are clear.
Confirmed. Proceed with the next excavation cycle.
Double-check the high-limit switch wiring on this motor.
Looks correct according to the schematic. We are ready for the sequence test.
Aligning the panel to the mark.
Confirmed. Tolerances are within spec. Secure the bolts.
The fan vibration levels look stable on the readout.
Good. I'm checking the shaft lining now. Seems completely dry.
We have a loss of power in the central tunnel. Activate the auxiliary system.
Auxiliary power engaged. Ventilation holding steady.
These projects represent a single, unified category of human achievement. Engineering projects that were not built where conditions were favorable.
Lock cycle on schedule. Water level nominal.
Confirmed. Proceed to next stage.
This seepage reading is approaching the amber threshold.
Yes, but it remains within the established safety parameters for the current load.
Deformation readings holding steady at section 3.
Acknowledged. Infiltration rates remain nominal.
Zinc. The deck acceleration is clearly visible, but well within the safe operating envelope.
Confirmed. The aerodynamic analysis.
Fluid level is stable at 4.2. No significant change from last quarter.
Understood. Recording status as normal.
Water flow stabilizing at 22,000 cubic meters.
Acknowledged. Group B reporting tension levels are optimal.
Metro access clear for the next phase.
We need to increase discharge immediately. Open gates 5 and 6.
Confirmed. Gates opening. Monitor upstream levels closely.
The flow rate on section 3 is fluctuating slightly.
Adjusting the deep outlets now to compensate.
The mechanical condition of the rotating machinery is within acceptable limits for continuous operation at full load.
The sensor on line 4 is fluctuating again.
Copy that. I'm zooming in on the deck cameras.
Please mind the gap while boarding. The doors are closing. Please stand clear.
Reading 172.5 meters.
Confirm that against the schedule for warp 1400 hours.
Team A, move to the access shaft. Secure the area.
Time elapsed. 3 minutes, 45 seconds.
Rainfall threshold exceeded at K250. We have slope instability.
Initiate immediate speed restriction. Monitor the next section closely.
Main structural stress levels remain stable.
Confirmed. All readings are within the safety envelope.
Monitor the freight speed near the passing lane. The Shinkansen is closing in.
Confirmed.
Adjusting the schedule for safe separation.
The reading is 42.5 millimeters.
42.5. Confirmed and logged.
We need more pressure on the starboard side.
Copy that. Increasing the flow now. Watch the splash zone.
The flood peak has passed through the reservoir safely.
Downstream discharge is controlled to protective levels.
The dam performed as designed.
Entering deep section. Speed restriction active.
Acknowledged. Systems green.
All systems reporting green across the board.
Confirming transit authorization for the next convoy.
Sluice gate hydraulics responding as calculated.
Confirmed. Discharge rate holding steady at 22,000 cubic meters per second.
We are seeing peak volume on the west span.
Structural integrity is green across the board. Adjusting signaling.
All gates maximum discharge. Repeat, maximum discharge.
The structure remains within the designed performance envelope.
All right, pull the drill. Switch to the chemical injection now.
Switching lines. Pressure stabilizing at 400 psi.
We are consistently exceeding the threshold at Tower 3.
The restriction order is ready. Confirmed to transmit?
Yes, send the order now.
The settlement is worse than expected. The deviation is at least 50 millimeters.
We can't just tamp this. We need the ground-penetrating radar now.
The air velocity is holding steady at the required threshold. The smoke layer is contained. Confirmed. The system is performing as designed.
Control, this is Vessel 802. We are struggling with the turbulence at the gate.
Acknowledge 802. Keep her steady, you are almost clear. Keep the pressure steady. Watch the flow rate.
Flow rate is good, engineer.
The measured deck displacement is within the design spectrum limits.
Confirmed. Cable tension is stable, authorizing continued operation.
All systems are currently green, despite localized warnings.
Threat approaching. Initiate flow.
Hokkaido-bound Shinkansen cleared the undersea section.
Freight train passage confirmed. All systems nominal.
All lines are showing green. Peak performance achieved.
Confirmed. Ventilation and power metrics are stable across the network.
Gauge pressure is steady at 500 kPa. Sump levels are holding. Everything looks good. Report submitted.
The naturalness of its presence, representing the ultimate success of extreme engineering. What was
purpose, educational purpose and informational purpose, using advanced AI tool and human creativity. All concept scripting and storytelling are independently developed to ensure originality. Visuals and animation are enhanced using AI technologies such as View 3, Meta AI and Grok AI, while final editing and post-production are completed using CapCut and other professional editing tools. No external creator content has been copied or used any resemblance to real world environment, factories or processes is purely coincidental. All scenes shown in this video are digitally created and do not represent real footage. This content is produced with transparency and follows YouTube monetization guidance. Thank you and subscribe for more real videos. Manufacturing Factory.